Hello students, today we are going to see how we find DTFT for a given signal. Here we are taking a small example. This is a question which was asked in the GATE exam in the year 2017. So what we have to do, we have to find the DTFT for a given signal. And the given signal is denoted by h of n. Like we can see it is a time domain signal and it is a discrete time signal as the time is denoted by n. So we are given a discrete time signal h of n and we have to find its DTFT. So how we denote the DTFT? It is capital H of omega. Now let us first understand the definition of h of n. We can see in the first line it is given h of 0 is 1 by 3. H of 1 is 1 by 3, H of 2 is 1 by 3, and H of n is 0 elsewhere. It means, as you know, like in discrete time signal, we have the values of the signal at integral values of n, like 0, 1, 2, 3, and so on. So here we have the values of H of n at 3 points only. That is at n equal to 0, 1, and 2. And at other places it is 0. So this is the definition of h of n. Now what we are supposed to do using the formula for the discrete time Fourier transform, we have to find h omega. So as you can see in the solution part, h of omega, as you know the formula, it is sigma n equal to minus infinity to infinity, h of n e raised to the power minus j omega n. This we did earlier. Now what we have to do, we have to add all these terms and we get the final answer. So we know that h of n is existing at only 3 points. That is n equal to 0, n equal to 1 and n equal to 2. And at all other places it is 0. So the summation will finally contain 3 terms only. So we get h0 e raised to the power minus j omega 0. Why did we put a 0 here in the power? Because when we take n equal to 0, the complete term contains the value of n as 0. In the next term, we get h1 e raised to the power minus j omega 1. And when we take n equal to 2, we get h of 2 e raised to the power minus j omega 2. So this is the value of the complete h of omega. Now we can substitute the values of the signal as we were given in the question. It was 1 by 3 for all the 3 points. So we put it as 1 by 3 in all the 3 places. So the final result of h of omega we get as this one. Now we move to the next part of the question. It says that for h of omega naught equal to 0 and omega naught is lying between 0 to pi, we have to find omega naught. So one part of the question is complete, like we have found h omega. Now we have to find omega naught for the given conditions. So what we do in the result, we replace omega by omega naught and equate it to 0. So I get h of omega naught is equal to 0 and I substitute the value of h omega by putting omega equal to omega naught, and this expression is substituted as equal to 0. On solving this complete equation, we get the final value of omega naught as 2.093. So why we have chosen this value? Because it was given like omega naught lies between 0 to pi. That means 0 to 3.14, somewhere in between the answer will lie. So this type of question is really important from DTFT. Okay, now it's the quiz time. So using the concept of DTFT, try to find out the DTFT for the given function f of n. So what is f of n? It is given as a raised to the power n un, where mod of a is less than 1. So let's try to understand the question. We have f of n. This is a discrete time domain signal and its definition is given to us. Here a is a number, like for example let a be 1 by 2. So mod of 1 by 2 is less than 1. This condition is satisfied. So A is representing a constant number in general. So we have to find out its DTFT, and the final result must come out as f of omega equal to 1 upon 1 minus a e raised to the power minus j omega. So let's understand how we will start this. We will initially take the basic formula of DTFT, that is, we will represent f of omega in terms of Fn, and how we substitute the values. Let's see. Now, why we have used this un? What is the significance of this un? You know, when we use the formula for DTFT, the summation is from minus infinity to infinity. But we know that the unit step function un exists only from 0 to infinity. So in summation, the negative parts of n are removed. Only the n values from 0 to infinity are taken. Only positive values. So what we do, this is a function of un, and un has a value of 1, so multiplication by 1 does not affect the answer. Now, we now remain with a raised to the power n. So a raised to the power n, we have to, in the summation, from where to where we have to add, we will add from n equal to 0 to infinity. So the various powers of a that will be coming into consideration are a raised to the power 0 plus a raised to the power 1, a raised to the power 2 up till infinity. So when you substitute it in the formula will become a series which is similar to the geometric series. You might have studied the geometric progression GP. It will be a GP series, and you already know the formula for sum to infinite terms of a GP. You can apply that and the final result you obtain would be something like this. Thank you so much. If you have any comments, you can post in the comment section. I would be glad to answer your queries. Thank you.